Now we are starting with different classification techniques. First one is classification by decision tree induction. Here we have different decision tree induction algorithms like ID3, C4.5, CART, etc. Decision tree induction is the learning of decision trees from class label training tuples. A decision tree is a flowchart-like tree structure where each internal node denotes a test on an attribute, each branch represents an outcome of the test, and each leaf node holds a class label. Here we have seen this example while we have introducing the classification and prediction methods. So once again you'll be familiar with this decision tree that is based on age attribute. We have three different categories: youth, middle-aged and senior. And if age and if it is a student, then class decision is no. And if age and it's a student, age is youth and it's a student, then the class decision is yes. And if the age decision is middle-aged, then the class decision is yes. This is based on the buying habit or the whether the customer buys computer or not. That is the case of no and yes. And if the age is senior and credit rating is high or fair, there is no chance of buying the computer, so the class label is no. And if it is a senior and the credit rating is excellent, then there is a chance of buying computer, so it is yes. So this is the example. The topmost node in a tree is the root node. Now let's see how are decision trees used for classification. Given a tuple X for which the associated class label is unknown, the attribute values of the tuple are tested against the decision tree. A path is traced from the root to a leaf node which holds a class prediction for that tuple. Decision trees can easily be converted to classification rules. So we are finding classification rules from the decision trees, and it is used for classification. Basic algorithms for learning decision trees include ID3. The expansion is iterative dichotomizer. C4.5, that is an successor of ID3. Then classification and regression trees, which is abbreviated as CART algorithm. These are some basic algorithms for learning decision trees. And this is the basic algorithm for inducing a decision tree from training tuples. We will come to this algorithm by studying the examples and the details. ID3, C4.5 and CART adopt a greedy, that is known as non-backtracking approach, in which decision trees are constructed in a top-down recursive divide and conquer manner. So it adopts a greedy method. All the algorithms follow the same methodology, but it has some difference. We will see that the algorithm is called with three parameters: D, that is the dataset, attribute list and attribute selection method. We refer to D as a data partition. Initially, it is the complete set of training tuples and their associated class labels. The parameter attribute list is a list of attributes describing the tuples. And we will see what is the meaning of attribute selection method. It specifies a heuristic procedure for selecting the attribute that best discriminates the given tuples according to class. This procedure employs an attribute selection measure such as information gain, Gini index, etc. Whether the tree is strictly binary is generally driven by the attribute selection measure. Some attribute selection measures such as the Gini index enforce the resulting tree to be binary. Others, like information gain, do not, therein allowing multi-way splits. You will see what is the meaning of all this by seeing examples. That is, two or more branches to be grown from a node. So attribute selection method um, is used for selecting the attribute that best discriminates the given tuples according to class. In the given example, we have selected age as the first root attribute or the first decision attribute. It is based on the selection using some measures. You will see how we are selecting such attributes for splitting the class tuples. The tree starts as a single node n representing the training tuples in D. That is the first step of the algorithm. If the tuples in D are all of the same class, then node n becomes a leaf and is labeled with that class. So if all belongs to the same class, then there is no need of splitting it again. So we will represent the leaf it as with the class label. Note that steps 4 and 5 are terminating conditions. All of the terminating conditions are explained at the end of the algorithm. Otherwise, the algorithm calls attribute selection method to determine the splitting criterion. The splitting criterion tells us which attribute to test at node n by determining the best way to separate or partition the tuples in D into individual classes. We will see what is the meaning of this splitting criterion and all. The node n is labeled with the splitting criterion, which serves as a test at the node. A branch is grown from node n for each of the outcomes of the splitting criterion. The tuples in D are partitioned accordingly. So here we are starting with a single node n, and it will represent the all the training tuples. That is only one partition. Then we will see whether it belongs to the same class. Then there is no need of splitting it, and we have different terminating conditions, and the algorithm will call attribute selection method for determining the splitting criterion. Then based on the splitting criterion, we have to split the tree, and we have to do this procedure repeatedly, and finally we will get a decision tree with many branches. So see this figure. This is an example for the possible cases of partitioning a particular attribute. We have different partitioning scenarios, and we will see the examples also. 3 possibilities for partitioning tuples based on the splitting criterion shown with examples. Let A be the splitting attribute. Here we have a splitting attribute like A. If the A is discrete valued, then one branch is grown for each non-value of A. So based on the nature of that attribute, we can split that attribute, and if it is of discrete value type, then one branch will be grown for each known value of A. For example, the attribute is color. If the attribute is color, we have different options of colors, that is red, green, blue, etc. And another example is income. We can divide it into high-level concepts like low, medium, high. So these are the examples for discrete valued attribute type. So the splitting criteria will be like this. And if A is continuous valued, and the attribute may be of type continuous valued, then 2 branches are grown corresponding to A, split point A less than split point and A greater than split point. So less than symbol is missing in this particular material. So you just add a less than split point and a greater than split point. And for example, we can say income that can be less than or equal to 42,000, and the right hand side will be greater than 42,000. So this is an example of continuous valued attribute type. And if A is discrete valued and a binary tree must be produced. That is the other case. Another case, that is A is an element of SA. Yes or no. That is a kind of binary type, and we can generate a binary tree based on this. For example, the attribute color which belongs to red or green. So we have only two branches, that is yes and no. So that is the binary tree. Then the test is of the form A is an element of SA, where S is the splitting subset of A. So based on the nature of attribute, the partitioning or the splitting criterion will be different. So these are some examples for partitioning an attribute. There are three possible scenarios. The same thing is repeated here. There are three possible scenarios as illustrated in the above figure. Let A be the splitting attribute. A has V distinct values, A1, A2 up to AV, based on the training data. So A is discrete valued, A is continuous valued, A is discrete valued, and a binary tree must be produced as dictated by the attribute selection measure or the algorithm being used. And we will decide how this attribute is selected based on the attribute selection measure. The algorithm uses the same process recursively to form a decision tree for the tuples at each resulting partition dj of D. The recursive partitioning stops only when any one of the following terminating conditions is true. So the algorithm will stop when any of these conditions become true. So first condition is all of the tuples in partition D, that is represented node N, belong to the same class. So if everything belongs to one class, so there is no need of repeating any steps involved in this particular algorithm. So we can terminate. Or the second condition is there are no remaining attributes on which the tuples may be further partitions. We have checked every attribute with the attribute selection measure, and we have no more attribute that is to be considered for partitioning the tree. So that is the case when we can stop the process. In this case, majority voting is employed. This involves converting node N into a leaf and labeling it with the most common class in D. Alternatively, the class distribution of the node tuples may be stored. Okay, so these are the another condition. This is a second condition for terminating the algorithm. And the third one is there are no tuples for a given branch, that is a partition dj is empty. So, for example, we don't have any number of tuples. Everything has been considered into separate groups or classes. So we have no more tuples. Then there is no need of partitioning the tree again. So that is the partition dj is empty. So we can terminate. In this case, a leaf is created with a majority class in D. The resulting decision tree is returned. Then finally, we will produce a decision tree. And we have seen that we have three things to consider. That is, one is D, that is the partition, data partition, and the second thing is attribute list, and the third one is attribute selection measures. So we are seeing what is the meaning of attribute selection, or what are the different attribute selection measures. An attribute selection measure is a heuristic for selecting the splitting criterion that best separates a given data partition D of class label training tuples into individual classes. These measures are also known as splitting rules because they determine how the tuples at a given node are to be split. There are different attribute selection measures, and some of the popularly used ones include information gain, gain ratio, and Gini index. We will see these measures in detail in the coming slides, but no need to study all the points. You just understand how these measures are used for splitting the tuples, or how it is used for creating a decision tree. So I will explain it with example, but the slides will contain enough points that will help you to read further if you are interested. But you just need to know the basics that I am going to explain. So I will explain these measures with examples. Okay.